Okay, we are going to solve problem 15.3 from Sadiku book, and the question is find the Laplace transform of this function. So Laplace transform of e to the minus 2t sine of 4t ut, and this is function that multiplied by ut, and ut means that this function is 0 when t is less than 0 or 1 if t is greater than or equal to 0. So this is the same as saying that this is the Laplace transform of e to the minus 2t sine 4t for t greater than or equal 0 or 0 if t is less than 0. And this Laplace transform can be seen in our Laplace transform lookup table here, and this is here in this form: e to the minus at sine omega t is equal to omega divided by s plus a quantity squared plus omega squared. So I already write that here, and we can just plug the value of this a and omega. So in this particular case, a is equal to 2 and omega is equal to 4. Therefore, the Laplace transform of this is equal to omega. Omega is 4 divided by s plus a is 2, the quantity of it squared, plus omega. Omega is 4. 4 squared is 16. So this is the Laplace transform of this integral. I mean this function. But if we don't have access to Laplace transform table, okay, let's prove that this will equal to this using manual calculation. Okay, let's erase this. Okay, by using the definition of Laplace transform, this function is equal to integral from 0 to infinity of e to the minus 2t sine 4t ut multiplied by e to the minus st dt. Okay, now we need to remove this term ut here, and because our limit of integration is from 0 to infinity and 0 to infinity is greater than 0, so this equal to multiplying this function, all of this function, by 1. So the value of ut is always 1 within this limit of integration. So we can cancel that. So ut is equal to 1. So we can rewrite this as integral from 0 to infinity of e to the minus 2t sine 4t e to the minus st dt. Okay, now we can combine the exponential term into 1. So I will have e to the minus, and we can take out the minus sign, s plus 2t here sine 4t dt. Okay, we have different kind of function here. We have exponential function and we have trigonometric function. So naturally we will use integration by parts. So here this will be our u and this will be our dv. Okay, if our u is this, so our du is minus s plus 2 e to the minus s plus 2t. Is it correct? Let's do check. Yeah, okay. And our dv is here, so we need to integrate that, and we will have minus 1/4 cosine of 4t. Okay, and we can now plug into integration by parts formula. So integral of AB of u dv is equal to uv minus integral v du. So this is the formula, and we can plug this into this formula. Okay, because it will be long, I will start from here. Our u is this and our v is this, so uv will be minus 1/4 e to the minus s plus 2 t cosine 4t, and we integrate this from 0 to infinity, so the limit of integration, and minus integral from 0 to infinity v du. Our v is this and our du is this, so we get minus minus become plus, and this still be minus, so this will be s plus 2 over 4 e to the minus s plus 2t cosine 4t dt. Okay, because this does not contain any t, we can remove this from the integral sign to the front. So we will have like this from 0 to infinity. Now let's evaluate this. This will become 0 at infinity because this e term, e to the minus infinity, is 1 over e to the infinity. 1 over infinity is 0. So 0, 0, and then minus. When this is 0, this will equal to 1, and this also equal to 1. So 0 minus minus 1 multiplied by 1/4. So this all will get us into 1/4. And then minus this s plus 2 over 4 integrated into 0 to infinity e to the minus s plus 2 t cosine 4t dt. Okay, now I think we will run out space if we continue from here. Let's stop and erase the whiteboard. Okay, so far we evaluate into this function, and for that we will need to do integration by part one more time or more, I don't know. So here we will have this as our u and this as our dv. Okay, and this is our u, so our du will be minus s plus 2 e to the minus s plus 2 t dt, and then our dv will be, our dv is cosine 4t, so v is integral of it, so it is 1/4 sine 4t. Okay, I think that's all, and let's plug all of this into integration by part formula. So I will have this 1/4 minus s plus 2 over 4, and we start the integration by parts. Then uv it is, okay, uv 1/4 e to the minus s plus 2 t sine 4t, and that's evaluated from 0 to infinity minus integral from 0 to infinity of v du. V du is this, so I will have minus minus, so I will have plus sign here, and then I will have s plus 2 over 4, and then e to the minus s plus 2 t sine 4t and dt. Okay, I need to close the parenthesis, and again this does not contain any t, so we can put the integral sign after this and treat that as constant. And now let's evaluate these parts here. So when t approach infinity, this term will be 0 because e to the minus infinity is 0, and when it is 0, the sign term will be 0, so this will cancel out to 0. So we only need to take care of this one. So we will have the function as 1/4 minus s plus 2 over 4, and this one is s plus 2 over 4 integral from 0 to infinity of e to the minus s plus 2t sine 4t dt. Okay, so if we look carefully here, this is the same as our initial integral here. So if we name this I, this will be also I, and so our equation becomes I is equal to 1/4 minus s plus 2 divided by 4 multiplied by s plus 2 over 4 times I. Okay, now let's multiply all of this. So I will have I is 1/4 minus s plus 2 squared divided by 16 times I. Okay, now we need to isolate the I. So I will be on the left hand side, so I plus s plus 2 squared over 16 of I, and that will equal to 1/4. Okay, now we can rewrite 1 here as 16 over 16. So we will have 16 plus s plus 2 squared divided by 16 of I is equal to 1/4, or I is 1/4 times 16 divided by s plus 2 squared plus 16. We just exchange a and b here, and this will cancel 4. So we will have this equal to 4 divided by s plus 2 squared plus 16, which is the same as we look from the table here. So the Laplace transform of this function is this 4 divided by s plus 2 squared plus 16. Okay, that's all. Let me know if I made any mistakes in the calculation, and thank you for watching.